on the DYU to make sure I address that. Number 11, as a general rule of thumb, do you measure someone's age?
Yes.
Sometimes. A lot of times. But you can use age as a categorical thing, but as a general rule of thumb, age is something measured, making it what type of variable? Quantitative. Generally, age is something measured as quantitative. Remember, cell phone numbers, even though they are numbers, do you measure or count to get someone's cell phone number? So it's not a quantity, it is a category. Okay, so it's categorical data. Yes, ma'am?
We did like one of these earlier. What was the one that like couldn't go?
That was the age. Remember, so that's what I was saying earlier, is you can use it to classify, and that's what I was saying, I think I caused some issues, so I let there be an extra free one in the DYU.
Oh, okay.
Age can be used as a classification system. However, my point is, generally, if someone just says age, you measure to get someone's age, it's quantitative. Okay. All right. Was there another one from the DYU, or is that it?
No, there's one more.
And check your understanding. What's up?
No, I was just, I think he had mentioned earlier about spring survey or something. Did we miss something about it in online that didn't mention?
What?
It was that, it was the
The parent survey. Your parents did it. Yeah, it was from the syllabus.
Someone wrote 17B.
Oh, I would have completely missed that. I'm so glad you said that, Ethan. Okay. So actually, this is exactly what I was just talking about with Andrew, so pay attention to this. So, which method describes a stratified random sample? So method 2, you separate the students into two groups, 850 who are members of school sports teams. Would that group be homogeneous or heterogeneous? Homogeneous, especially in respect to how they feel about building a new parking lot to replace the practice fields. And 2,750 students who are not athletes, right? And then they give the survey to a simple random sample of 85 and 275. So first off, a simple random sample from that group makes it very clear, hopefully, that it's a stratified random sample. Do not forget, though, the largest benefit of a stratified random sample is it guarantees I get perspectives from both sides. And I was talking about with someone during first block, the other thing is it gives it to you proportionally. Because if I got, 360 students, if I got 180 who are members of sports teams and 180 who are not on sports teams, am I proportionally representing those groups? No. Definitely not, right? Because 180 out of 850 is a high proportion of these, whereas 180 out of 2,750 is a much lower proportion. So I don't have an accurate representation of those two different groups. But if I do 85 of 850 and 275 of 2,750, I'm getting an accurate, proportional understanding of those two groups. So that makes it stratified, and I get to accurately see those two different groups.
Okay,
Yes,
so
Ian.
the notes you gave me for this one was what does a homogeneous strategy guarantee?
That strata. That. It guarantees that I get each group proportionally represented.
Okay.
It guarantees that I get 10% from school sports teams and 10% who are not on school sports teams. So it guarantees that those two different groups that may have different responses, I get them in a proportional manner. Yes. So I get them both represented well. Yes, Raina.
Oh, and I know where they're talking about 17. So for me in 17B, I wrote method 2. It reduces variability, and I got partially right. And I want to know what more extra details that the test runs.
Well, you're right that it is reducing variability, and that is good. It made a more precise estimate, but it's just what I just talked about. It guarantees. Why is it a more precise estimate? Because it guarantees that I get people from both groups at a proportional rate. Right? So why is it a more precise estimate? Because it gives me representation from both groups at a proportional rate. Okay? And then, let's check your understanding. Specifically describe randomization. So this is
do your understanding.
the check your understanding on 4.6?
Yes, sir.
I think I have that in the slides. Nope. Okay. So as I said, I'm going to make scans of the Fourier models. I might quickly run while I have y'all working on something because it takes me 5 seconds, really a minute to make scans. But we're going to finish up components of an experiment and get into the elements of a well-designed experiment. Specifically, we're going to talk about one of the things that is hard to see the difference initially, but is wicked important and it's easy enough to master, called blocking, okay? So make sure that you pay attention when we talk about blocking soon. It is the start of 4.7, okay? And then you also wanted me to go over learning target number 1 from 4.6, Raina, is that right?
Yeah, I think the reason that I did was the D that I had a question about and
It's tied into that?
notes. I think they're closely related, but
Yeah.
it was on concept, not actual applying.
So, what did I say for the learning target number 1? I talked about...
Well-designed experiment number
Yeah, sorry, I
one.
was stealing. So, for a well-designed experiment,
Number 1.
I mean, I only need learning target number 1. So, a well-designed experiment needs 4 things.
Yeah.
And we're going to go into more later. So, I do want to point this out. A well-designed experiment. What's the whole point of an experiment?
To find cause,
To find a causal relationship, to establish cause and effect. What type of variable can prevent us from accurately understanding cause and effect? Confounding, right? So everything in a well-designed experiment is about confounding. Now, I want to point this out just to make sure this is clear. When I say components of an experiment, I'm talking about explanatory variable, response variable, treatments, things like that. Those are the components of an experiment. The elements of a well-designed experiment are comparison. We have to be able to compare what?
2 or more treatments.
2 or more treatments, right? We have to have random assignment to those treatments. Why do we need random assignment to treatments? Close.
Reduce variable.
reduce confound.
Reduce the effect of confounds. Now, please pay attention to the language there. Be careful. It's not to reduce confounds. It's to reduce the effects of confounds. So don't forget, Charlie. Bias is in sampling, not in assignment, right? Random sampling reduces the bias in observational studies. Random assignment reduces confounding in experiments. So we have to be careful on bias versus confounding. That's a detail we really have to hit on. And sampling versus sampling versus assignment. This reduces the effects of confounding because it ensures that we equitably distribute those confounding factors. So like with the SAT thing, can I control how much sleep someone gets the night before? No. But if I randomly assign you to different treatments, have I kind of balanced out the elements of amount of sleep the night before? Right. That's the idea of random assignment, is that I can't control these things, but I can randomly assign to treatments so that they're equitably distributed, okay? The next one, replication. If I only do the study once, am I going to get convincing data? No.
More than one in each treatment.
Yeah, more than one, and really as many as possible. And then we have control, and that's when we keep other variables constant, right? So if I could, would it be great to say everyone gets 8 hours of sleep the night before?
Yes.
Yeah, that would reduce the effect of the confound of sleep. However, is that realistic?
No.
No, I bet Star gets all of like 4 hours of sleep at night. Tell me I'm wrong. I can tell. I know those students. All right. It's not a bad thing, it's just you can tell. All right, so these are the elements of a well-designed experiment. Now be careful and please note, control is different than a control group. A control group is a group that gets essentially no treatment. The treatment is that it doesn't get anything for you to compare against, right? So the control group is the group that doesn't get anything. Maybe they get a placebo to see does the medicine actually work or is it you feeling like you're getting the medicine. Okay, so that placebo is there. Now, for your question, create an outline showing a completely randomized design for the experiment. This is actually not one of these things.
Oh.
This D here is what we did at the beginning of the lesson, and it's the first part of the lesson I asked y'all to start looking at. So, how do we show a completely randomized design? Well, I will say this. Anyone know which of these elements goes with the idea of randomly designing the experiment?
Random assignment.
That's just random assignment. I will say that. That is asking for random assignment. So what do we need to do? Group of researchers in Africa find a creative way to protect cattle from lion attacks. They paint eyes on the cow's rears. To determine if this treatment is effective, they randomly assign the cattle to one of 3 treatments. Eyes on the rear, cross marks on the rear, or nothing on the rear. After 4 years of roaming the plains, the cows with eyes saw no deaths, the cows with a cross suffered 4 deaths, and the cows with no marks suffered 15 deaths. So, how do we start this?
Label each cow a unique identifier from 1 to 1200.
Okay, so we're going to label each cow 1 to, it doesn't tell us how many cows there were. Oh, 1200, perfect. It's in part B. So 1 to 1200 with a unique identifier, right? That's the label part. And what they want, I will say, is they want an outline. I would just write this out, but this is what Mathematic regularly does. So we label each cow 1 to 1200 with a unique identifier. What comes after that labeling method?
You need to generate 1200 numbers using the RNG.
Generate how many?
Generate 300, 400.
400.
Generate 400 unique identifiers with a random number generator. And what are they going to get?
Eyes on the rear.
So eyes on the rear.
The others.
Okay. Then what do we need to do next?
Then assign the next 400 to cross marks on the rear.
The
Ow.
other.
Generate 400 more.
We need to generate 400 more because we can't just say assign the rest or anything like that because we've got 2 more treatments. So generate 400 more unique identifiers with a random number generator. And this is why I like to just write it out. This is their outline idea. But we generate 400 more unique identifiers with a random number generator. What do we want to say? They get a cross
Cross mark.
on rear. And do notice we have to say 400 more unique identifiers. We don't want any repetitions in there. Yes, Ian.
Okay, like when I was doing this last week, I wrote 1200. Why couldn't you just generate 1200 at once and then split them up by 400?
I think it depends on how many treatments there
Well, we have to label each cow 1 to 1200. There are 1200 cows. I'm not sampling, I'm assigning. So label each cow 1 to 1200. Then we need to generate 400 of them. Now what you could do, I just wouldn't do this. What you could do is you could go to the first cow and generate a number 1 to 1200 and give that cow that number. Next cow, generate another unique number 1 to 1200. And then the first 400 get the first treatment, the next 400 get the next treatment. But then you have to randomly assign the numbers to the cows rather than just label them and generate unique numbers. This is a more efficient path. Okay? And then notice I don't have to generate any more. I just say the rest get no, how do they word it?
Mark.
No marks, nothing on rear. Okay, so what do we do after all of this?
Assign.
Well, we already did that. So generate the unique numbers, and by doing this arrow here, I've assigned the treatment. I prefer a paragraph format where you just write out and explain, assign those cows to this treatment, repeat the process for 400 more unique identifiers, assign this to the second treatment. This is what they mean when they say an outline though. But what do we do after we assign these treatments?
Compare the results.
So compare, what are the results?
Compare 3 treatments.
So compare the number of what?
Number of deaths.
For each
treatment.
treatment. So that's how it is, right? We split them up into these different treatments, then we bring all that data back together to compare those, the number of deaths for each treatment. Okay. Does that answer your question, Ryan? Okay. Ian, do you understand that slight change to just be more efficient?
I think so.
It should, I'll say this, it's just, what you're doing, it's doable. And like, there's other ways to do this as well, so I'll give another example in a second. But it's doable to do other forms of random assignment. Overall though, it's much simpler to just label your sample and then randomly generate 400 to get first treatment, 400 for the second, and the rest get the third. Another possibility is, so hold on, I got you, Dixie. Another possibility is, you go to the first cow, you randomly generate a 1, 2, or 3, and then a 1 gets eyes on the rear, a 2 gets a cross on the rear, a 3 gets nothing on the rear. And you just keep doing that until you get 400 in one treatment. And then for the rest, you keep going until you get in with 400 with a second treatment, and then the rest get the third treatment. It's just a little convoluted to say it that way. This is a simpler way to do it. I've seen them accepted on the AP exam, all 3 of those ways, but you have to be careful. This is straightforward. You label your individuals, use a random number generator to randomly generate however many unique numbers, and then go. Dixie, what you got?
So like, would D be the same as B? Or is that all like?
So this is the first part of this. The outline is this full thing, right? Where you bring it back together at the end and you compare the number of deaths. That's the difference between B and D, okay? This part here is just the first step here.
Yeah, because that's like, when we were doing D, like I had everything already reviewed, like.
But then you
Review
add
is
in
like
that
that.
last bit of comparing the number, yeah. But again, and the other thing is they say create an outline, right? So in that outline format, it's like this. I would just write the paragraph. That's all I would do. Okay? Yes, Raina. And then we gotta go.
Oh yeah, can you just review the thing of the term called level? I was looking over the text with them.
So in the context of this, these are my treatments, right? These are also my levels, because the explanatory variable is the treatment of something on the rear of the cow. And then it's split into, and then after the explanatory variable is the factor, right? You always have levels. So these are my levels, but because there's only one thing in each level, those are also my treatments. A contrast to that is, if I am looking at, and this one I always go back to because it's easy. If I'm looking at plant growth, there are quite a few levels that we could look at within the, no. There are quite a few factors we could look at. Factors being rain, factors being sunlight, and factors being soil, whatever, percent of carbon dioxide, whatever in the soil, right? And then within rain, that factor, I can have levels of 1 centimeter per day, 3 centimeters per day, and 5 centimeters per day. So those are the levels within this factor. So these are my levels within the factor. The amount of sunlight, I could say 12 hours of sunlight, 16 hours of sunlight, 20 hours of sunlight. These are the levels within the factor of sunlight. But then the treatment would be 1 centimeter with 12 hours, 1 centimeter with 16, 1 centimeter with 20. It's that combination of the levels. So if there's only one level within each factor, then the level is the treatment. But if I have multiple levels within each factor, I have to find the different combinations of my levels to get the treatments. So 1 centimeter of rain with 12 hours of sunlight a day, 1 centimeter of rain with 16 hours, 1 centimeter with 20 hours, or 3 centimeters with 12 hours, 3 centimeters with 16, 3 centimeters with 20. 5 with 12, 5 with 16, 5 with 20. So I have 9 treatments. Okay. So that is a small but important detail to pay attention to. Okay, I just want to point this out. This is something I started doing, I thought about this morning, so I updated my slides literally this morning to account for this. I'm highlighting in green the things we have already studied and we should know how to do from this proficiency scale. So from the foundation, in green, we've covered all these different terms and we've identified questions to be answered from the data collection method. So that's talking about causation or generalizations, determining if data and or questions are categorical versus quantitative, samples versus populations, determining what type of study we have. Today and for the rest of this unit, we have talked about this, but we're going to continue to build on the idea of the importance of variation in statistics. Don't forget, sampling variability. Different samples are going to produce different results. That's sampling variability, right? And that's important in the idea of statistics. So there's a lesson today at the end of class, towards the end of class, that'll address that more heavily. On the target section, we covered all this in green. Blue is what we're about to hit. Randomized block design, matched pairs design. And so this is going to be the last couple elements of a well-designed experiment. And we're going to compare experimental designs, okay? The next lesson is all about statistical significance and scope of inference, okay? By the way, I looked at sampling with versus without replacement, and I realized why the textbook actually lays it out. If you didn't look in the textbook, it would have explained it well. The reality is if you use a random digit table or you use a random number generator on a calculator, is it possible to get the same number more than once? Yes. So the calculator uses sampling with replacement. We have to be aware that if we get a number more than once, we got to skip it and go again because we sample without replacement. Should have thought through that. So we don't usually sample with replacement. We will talk in inferential statistics about when we don't have to worry about that as much, but we don't sample with replacement, but the calculator does. That's the big idea there. Make sense? Good with that? All right. So let's get going. So does type of SAT prep matter? This is actually the one. Is this the next lesson, this 4.7?
Yes.
Day 2? Okay. So we've already done this a good bit, right? We started on does SAT prep matter 2 lessons ago, I think. Or was it last lesson? One of those 2. So draw an outline for a completely randomized design to compare the 2 treatments. I did ask y'all to do this. I'm not going to assume that we did, but we're just going to have to go through it to get to the next part. So what's going to happen first?
Randomly sample.
Can't start at randomly sample. Well, first off, are we going to do random sampling here?
Identify treatments.
Applied treatment.
You gotta label.
Thank you. What's the first part of a random design process? We got to label. What are we going to call the individuals in an experiment?
Subjects.
Subjects if they're people. What's the broader term? And I just want to bring this back in.
Experimental unit.
Experimental unit. So remember, when they're humans, we call them subjects because they are people, so they're not just experimental units. When they're not humans, we call them experimental units, okay? All right, so label who are these subjects?
Students.
Okay, so label the 50 students. The subjects. 1 to 50 with unique identifiers. All right, we've labeled them. Now what?
Randomly generate.
So randomly generate. Generate what?
25 will be the online.
You just randomly generate 25 non-repeating numbers.
Okay, or just
Unique.
unique identifiers with a random number generator. Don't forget, you gotta say with a random number generator. So that's truly random. And I've realized this is really what I should have done, is draw the arrow, we randomly generate. Once we generate those 25 unique identifiers, that's not how you spell identifiers. What do we do next?
You need to assign the first 25 to a classroom or an online.
So assign, well, you gotta make a decision. So assign those
25
students online. Is it online prep?
Yes.
Is
Online teacher.
online
Wait.
teacher?
Yeah.
And it will be offered
It
in,
says online.
it's an SAT prep class though, right? So online teacher for test prep. Don't forget your context, right, for test prep. Okay. Do I need to randomly generate 25 unique identifiers again?
No.
No.
Throw the rest.
The rest takes.
So the rest, I'm just gonna kind of draw a long arrow to get to here. So the rest receive test prep from a classroom teacher.
Wait, I'm confusing, because, why didn't we do that with the check your receiving?
Because
We
they have
did.
three,
There were 3 groups, rather than
like,
just.
Oh, so you can't assign.
So remember, with the 3 groups, we randomly generated 400 to get treatment 1, randomly generated 400 more unique ones to get treatment 2, and then the rest got treatment 3. It's it's whatever the last treatment is, that's what goes there.
Okay, perfect.
Okay? All right, what do we need to do now?
Compare.
The,
Compare what?
compare
Test scores?
SAT scores.
So compare SAT scores for the treatments. Notice I am focusing on the treatments themselves, right? What?
Not a 10.
Okay. Yeah, same thing. All right. Everybody got that down?
Not yet. Okay. Okay.
Okay. We can give you a minute or so to come up with a couple of issues to address A. But of the 50 students that signed up for the prep course, 30 are juniors and 20 are seniors, and the counselors are worried that the random assignment could potentially put all the seniors into one of the treatment groups. Now, is that likely?
Yeah, no,
Yes.
it's not likely, but it's possible.
I was gonna say, it's not likely that all 20 are in the same treatment, but it is possible, right? 20 out of 25 in one treatment group. So it's not possible, or it's not likely, but it is possible. Why would this be a problem? Talk with your small group, why would this be a problem?
Yeah, probably because they're gonna combine it from that's why they probably want to perform on the Oh, yeah.
No, absolutely.
Let's see, like,
He's thinking it's fun.
Yeah, I know you're thinking.
So they're gonna care about
Any other explanation for why it might be problematic on your other side?
Oh yeah, that is a compound.
I mean, it's true, but like how are they, so like you're saying, hey, seniors have been doing it longer, they have a whole extra year of experience, so they might be wiser, right? Not necessarily wiser. What I'm asking is there a flip side to it where it could be, so what you're essentially saying is, well, you think maybe the seniors would do better overall? Oh, you don't think that? But you're talking about like one person,
Take the.
right? It's possible.
Like Jaden Dow compared to like.
I agree with you on that. I think it's just.
Jaden Dow's a, like,
You should have.
no,
Is it really gonna compare anyone to David Dow like at all though? You know, like that's not a fair comparison. So I'm gonna talk about both things. Alright, so what could be a problem with all of the seniors getting one of the treatments?
It won't accurately reflect.
Because the seniors
So-
are more experienced, probably big CT or the.
Okay, so seniors, so it's possible that seniors have more experience with standardized test prep, right? For standardized testing.
There's also a possibility of seniors taking more AP classes and honor classes. I think it goes on inside the boundary of the first one.
So yeah, one, that still goes into the idea of seniors have more experience with standardized testing. So here's the thing, what do I want to know?
The overall school, of the 50 students.
The conference.
I want to know the effect of the test prep, right? Do I want to know if seniors have more experience with standardized testing?
No.
No, right? So that means that they could be scoring better. What did you say?
Senioritis.
Okay, do I want to know about the effects of senioritis?
No.
No, right? That could also be a problem.
What's senioritis?
Okay, does anyone, and so Laura, you had your hand up earlier?
Like seniors, they're getting closer to applying for college and stuff.
Okay.
So they need to get their scores up. And
So
they're
higher
probably gonna take it-
pressure,
They're probably gonna
more
take it more
motivation.
seriously.
more motivation, higher pressure to perform well. So maybe they're working a little bit harder. Okay. I will say this, does anyone have any others that they could add in here?
Emerson's
No,
motivation.
we all have the same.
Yeah, it says more motivation.
More motivation, I think that's the higher pressure to
The higher
perform well,
pressure.
yeah. What about this? And I'm not saying this is always the case, but generally speaking, especially if we're talking about like late sophomore year, early junior year, which group of students are taking the ACT or the SAT early junior year?
Me?
The smart.
Smart
The ones
people.
who are gonna perform better.
I was saying, the ones who are more intrinsically motivated. Like right here, yeah, seniors get high pressure to perform well, right? But like if you're taking an SAT or an ACT at the end of sophomore year, beginning of junior year, you're like, I'm ready to crush it, right? So you're feeling confident, you feel like you're ready to go. I think Jathan took it, what, his freshman year?
Oh.
And like, you know what I mean?
Saying this,
You know, like,
right?
I understand, that's my, I know, but my point is, right, that like if all the seniors get in one group, that means almost all the juniors are in the other group. And so, so seniors have higher pressure to perform well, juniors, you're excused,
So
might
like,
be.
so like they like mostly like have the same outcomes in it since they're like both have that motivation, so like there's no like actual comparison.
And so, yeah, so what are all four of these variables? I don't know which one it is.
Confound.
These are all confounds, right? Are all of these related to the explanatory variable, the test, which test prep class you have?
No.
No.
I mean,
Oh, they have.
they're related to, they're not necessarily predictive of, but could these be related to which test prep class you have?
Yeah.
Are they predictive of how well you do?
No.
Well, yeah.
Yeah.
These variables?
Yeah.
Yeah.
If you have more experience with standardized testing, will that help your score hopefully go up?
Yes, it's just not.
If you have senioritis out the wazoo, is that gonna affect your score and make you go down?
Girl, why are you looking at me?
I know, right? Okay. Will that make the scores go down though?
Yeah.
Yeah? If you are feeling the pressure to perform well, are you maybe gonna work harder?
Yes.
So all of these are confounds. They are related to the test prep because of whether you're a senior or a junior, but also they are predictive of your scores. Yes,
Can
Ian?
we say their compounds? Do we have to say their potential compounds?
Ah, thank you. Yeah, these are potential confounds. Yeah, do we actually know for sure that they will confound our
No.
results? No. And I will say that, I don't know if I ever actually said that with bias, but we do need to be clear about this. We have potential sources of bias, we have potential confounds, we don't know them for sure, right? Dixie, you had your hand up first.
When we actually like identify like if it's whether like potential compound or actual compound.
You don't, you always call them,
Potential.
yeah. Yeah.
Nothing that's ever.
We don't, I'll say this, in statistics, it's very rare that you're like, this is a thing, because it's like, we think it is, there's evidence. Ryan, what's your question?
So, it is it would be, the potential confounds here would be a actual confound when the seniors are actually in, like, all whole seniors are in the one group.
No, they would be potential confounds, I'm glad you asked this question. They would be actual confounds when they actually mess up my understanding of the cause and effect. Will I ever know if they actually caused a misunderstanding and cause and effect? No, so what are they always going to be?
Potential.
They're always going to be potential confounds. Well, that's all about potentially putting the seniors in one of the treatment groups. Okay, B, how could we adjust our experiment though to eliminate, or I would say really reduce, but eliminate this potential problem? Draw an outline of the experiment with your modification. So what do we need to do to change this so we don't, ooh, that's close, but stratified what? Stratification is a type of,
Blocking.
hold up, back up. Stratification is a type of what? What was it? Sampling. Stratification is a type of sampling where we create homogeneous groups, right?
Right.
Okay, Ian, do you know what we call it in an experiment when we create a homogeneous group?
Blocking.
Oh, it's called a blocking system.
Oh, come on.
Oh, come on, it's like it was in the proficiency scale that I told you this is what we're about to cover, right? I know, this is wild, right? So, we're going to block. So, who are we going to block together?
The juniors and then blocking the seniors.
So, we block our juniors together, and then we block our seniors together. Notice this is a whole lot like what that someone mentioned over here earlier. Stratifying. Hey, guys. Well, hold on. Listen. Blocking in an experiment is like stratifying in an observational study.
Right.
Okay? These are homogeneous groups. I think that was one of the things that threw me off for the longest time, and when I understood that detail, it made things make a lot more sense. So these are homogeneous groups, because I was worried that seniors versus juniors might mess up my results. So homogeneous groups, like strata, but we call them blocks. All right. Now, how many juniors were there again?
30.
30?
I was waiting.
They told us.
Where?
In the question.
Oh.
Okay, so what are we going to do from here? Yes?
You can use any observational study sample techniques on experiment.
So you can, if you're collecting a sample first. This is random assignment though. So random assignment is I have a sample and I'm assigning to treatments. If I'm using sampling methods though, I used random sampling to get this. Now remember, random sampling reduces what? Bias. But do we worry about bias in experiments?
No.
Because bias is what prevents us from making a prediction from sample to population. We only care about cause and effect. Okay? So blocking is here. Alright, so we're blocking. We're worried about the confounded juniors versus seniors. Okay, so what do we do from there?
You will give a label each with
Ah, there we go.
identifier.
So label each junior with a unique identifier. Am I done with my description right now?
No, 1 to 30.
It's gotta be the 1 to 30. Should be implied, should be understood, yet they don't let us do that. Okay, so label each junior with a unique identifier, 1 to 30, and then we're gonna do the same thing with seniors, but it's gonna be 1 to 20.
Mr. Penny?
Yeah.
When we call strata when it's,
Sampling.
Sampling
Sampling with observational studies.
yeah. So what do we call the block, the blocks inside if it's an experiment?
It's blocking, it's called a randomized block design, but it's part of the random assignment. So it's just called blocking. Alright, so what are we gonna do after we label? Generate what?
30 numbers.
1 to 15.
I would say, not 1 to 15, so generate,
Oh, 15. 15 numbers.
Using a
generate
random number.
15 unique numbers.
Using a random number generator.
By the way, don't forget, from 1 to 30, right? So it can't be any 15 unique numbers in the world, it has to be 1 to 30 with an, I know, it's such a small detail and it's so goofy, but it's there. Alright, what are we going to do with those 15 unique numbers?
Throw them in the
Assign
online
them the online treatment.
So assign them online. class? Alright. What are we gonna do after this?
The rest.
Assign the rest in the in-person.
So rest, get in-person class. Really should do. That was cute.
That was disgusting.
Excuse me.
Alright, what's gonna happen with our seniors now?
Half of
Same thing.
Late,
generate
10.
So generate
10.
10
Yes. Unique.
unique
From 1 to.
identifiers, 1 to 20, with a random number generator. And what's gonna happen to the, ooh, 10 unique? What's gonna happen to them?
Online.
Assign them online. Notice I just kind of drew an arrow to that one treatment. Assign them to online class. And then what's gonna happen to the rest?
In person.
You do the other arrow.
The rest get in-person class. Now, I have ensured that the juniors and seniors are equitably split up among the online and in-person classes. And the bell's gonna catch us there, and we're gonna finish this up after lunch.
What's time to go?
Yep,
no.
you leave forever, bye.
Stop.
I may shift things back, however, that means we'll start the next unit before we take the test. Cause like, I have to make sure we get content in at an appropriate pace, but I'm gonna think on it, I'll let you know. The DYU, I'll let you know at the end of class. I'm gonna think while we work. Alright, we gotta get going though. So, a couple of quick things I do want to point out, I want us to be careful about, because I was checking myself on this. So, first off, we got 50 students. Make sure when you do an outline like this, you're gonna block your juniors, block your seniors. Please do note those are homogeneous groups for assignment, not strata. They're like strata, but that's for sampling. Those homogeneous groups are called blocks, because we're worried that the juniors and the seniors might be different. Yes, Lorelai?
I did have a question about the test. Is it gonna be like the BYU's?
No.
No? Okay. Is it,
Okay, the AP exam itself is 40 multiple, hold on. The AP exam itself is 40 multiple choice questions and 6 free response questions. And half of your score comes from multiple choice, half of your score comes from free response. So what I do is, I do 8 to 10 multiple choice questions, and that's gonna be half your grade, and then I'm gonna do 2 free response, which is half of your grade. So like, that's one of the biggest benefits for getting for my classes, and that's what some students have said year after year, is that when they get to the AP exam, they're comfortable with the way the AP exam is set up, because that's all we've done all year long. Okay, so my test will be set up just like the AP exam. Okay? We gotta get back to this soon. What, Brandon?
Just so quick, is this back due tomorrow?
Yes, that's the plan.
Got it.
But hold on. Alright, so we label each junior with a unique identifier 1 to 30. Generate those 15 unique numbers from, oh, this is what I wanted to say. So we had all this. I went back and I checked myself. One thing to be aware of is I'm actually not going to draw a label all the way to this assign the class, because the whole idea is that the class, junior versus senior, could be a confounding variable, right? So I don't want to throw my seniors in with my juniors. What do I want to do after this layer right here? So I've got my data, what do I need to
Compare
do?
that to the other set of juniors.
Yeah, so I'm only going to compare juniors to juniors, and I'm going to compare seniors to seniors. Okay? So I readjusted the arrows there, so please note those arrows are not exactly the same. Notice we still have assigned this group to online class. I still have assigned this group to online class, and classroom teacher, but what's going to happen after this layer is we're going to compare our data. So after the treatments, after we collect data, compare treatments.
I have a question.
Go for it.
So if they're all mixed into the same class, would it really matter if you compare? Like, you would be comparing individually, you'd be comparing in class, right?
No, you'd be comparing individually. So you would collect data from the juniors who are in the class, or online, and the juniors who are in the class, and you're gonna, and I will say this, you're gonna find the average of these students and the average of these students and compare those averages. but I want juniors versus seniors. Because I want to know I want to know, is that online class or that in-person class improving for juniors or for seniors or for both?
So junior versus senior?
No,
Junior versus junior.
junior versus junior,
Okay.
senior versus senior. So I look at them separately so that I don't have to worry about that confound. Think about it this way. Remember how we talked about direct control of confounding variables? By blocking like this, I've essentially directly controlled for the confounding variable of junior and directly controlled for senior. And I compare the data from the seniors with each other, and I compare the data of the juniors with each other. Okay? So I just compare juniors to juniors, seniors to seniors, because whether you're junior or senior could impact the results. Okay? All right. So there's B. We got our updated randomized outline. Got that ready to go. All right. So here's something different though. Number 3, the counselors are also worried that the random assignment could potentially put all the super hardworking, high GPA students into one of the treatment groups. They have a list of the 50 students and their GPA ranked from highest to lowest. How can they use this list to help them set up the experiment? Ian?
You can block students into 2 groups with 25 people in each group.
Okay, so you're going to block the top 25 and block the bottom 25?
Yes.
Can anyone think of any other blocks that might work? We don't want, well, first off, cluster is a type of what? Sampling. We don't want clustering.
I don't, pair from the end be like first, the highest to the lowest.
Well, so you're saying take the highest and pair them with the lowest?
Yeah.
And what are we going to do with that pair?
Since it's 50 students, it's gonna eventually get, when we do this, select pair by pair, it's going to be, and there are 2 groups of 25 students, so.
Okay, but remember, our blocks need to be what?
Homogeneous.
We want our blocks to be homogeneous. Is that a homogeneous block?
No, that's right.
So it's very different. Ian?
You could do 5 groups of 5, like say 5 students who make
So
two
top
A's,
5.
then the other group who makes B's.
Well, we don't know. I mean, they could be all.
Like
Almost all A's, right?
hypothetically.
Well, so what about top 5, next 5, next 5, next 5? That's terrible. And then the bottom 5. So can we do that in groups of 5?
Yes.
Any other groups we could do though? You're getting closer to what I'm trying to get you to see.
GPA.
Well, and we're using the GPA to determine top 5, next 5, etc.
Can you give us like a little hint or something?
It might be somewhere on the proficiency scale.
Match pair, I go look up everyone, but like in fact, they can get GPA, like all the 4 points together, all the 4 points together, or 3 times never.
But you can get even more precise than that. What were you saying about it, Star?
Match pair.
Matched pairs. So not the top 25 and the bottom 25, not the top 5 and the next 5 and then the next 5 and then the next 5. Matched pairs. So pair them, but that's not the pair I would want.
Like systematic?
That's systematic, that's type of sampling. What are you saying? Sorry, Lacey.
Is it, by match pairs, you mean like highest highs?
The highest and highest. So
Yeah.
what about class rank 1 and 2?
Yes.
And then class rank 3 and 4. So remember, we want our groups to be what?
Homogeneous.
Homogeneous. Can you get more similar than those? Those two? No. Can you get more similar than those two? Right? So there's, and so Rand, this is what we want to be careful about. We don't want to pair the highest and lowest, because what am I going to do within those blocks? So remember, from the block, we randomly assign to the treatment.
And it needs to be homogeneous, yeah.
Yeah, but if I give the highest person the in-person class and the lowest person
It's
online,
not heterogeneous, it's heterogeneous.
yeah. So what do I need to do with this block, this pair? So, not SRS, because that's a simple random sample. What do I need to do?
RG.
I need to, yeah, that's just a random number generator. I need to randomly assign. I need to randomly assign with an RNG, right? So randomly assigned, and so one student gets what?
The
Online class. And one student gets a classroom teacher. And then what are we gonna do?
Compare.
We're gonna repeat, but also we're gonna do what with that data?
Compare it.
Compare it. Now, here's the one thing I will point out. And so this is gonna be a little bit different. So right here, I didn't talk about this. Here, what we're gonna do is we're gonna find the sample mean of the online class and then subtract the sample mean of the classroom teacher. So we're gonna find the average of these 15, and we're gonna find the average of these 15, okay? But because we're finding an average of here and an average of here, there's still gonna be a lot of variability. And we're gonna talk about this in more detail later. But over here, because we only have 2, we're going to actually find the nope, not the means. We're going to take the value of the online class, the value of the classroom teacher, and we're going to get a difference. And we're going to average all the differences here, because this is going to actually reduce variability. Now, you don't have to know that yet. I'm just giving you a preview of what we're going to go into. So, when we do a block design, we find the averages and then subtract them. When we do a matched pairs like this, we're going to find the differences, and then we're going to average all the differences. Okay? And there's relationships there. Don't sweat it a lot. I just want you to see that. Let me see, I'm going to check one thing on how mathematic at least set up. If they said anything else with that. No, that's not the one. Yeah, so they just literally, and I hate that. So they didn't even do an outline like this, which is exactly, I wouldn't either. They just did it verbally. So let's describe what we're doing. So what's going on?
We're pairing.
So we're pairing, so pair up.
2 like students.
How do you determine if they're like?
By their class rank.
Okay, so pair up students by class rank. Well, yeah, you can add that detail if you want. Class rank, so 1 and 2, 3 and 4, 5 and 6, etc. All right, so what are we doing after we pair up students by class rank?
Split them.
Randomly assigned.
So we have to, we don't have, yes, we're going to randomly assign, but like how are we going to randomly assign?
With a
Random.
So how are we going to use a random number generator?
use a generator number 1 to 2.
Okay, so
Oh my gosh.
use a random number generator to generate a 1 or 2.
1 to 2. Unique.
Well, you don't have, because we only have 2, we don't need a unique this time, right? So use a random number generator to generate a 1 or 2, then what?
Assign.
Assign who to what?
Assign 1
The
for,
first chosen.
for online and the other, yes.
So we're going to have to be careful with the way we describe this, because you said the first one chosen, but we just said a 1 or a 2. When we get to 3 and 4,
Oh my.
you would have to worry about it then, right? So you can do a 1 or 2. That student gets the online class, then you get to the next pair, a 3 or a 4, that one gets the online class. You can do this, though. You can use a random number generator to generate a 1 or a 2. If a 1 is selected, or generated, then the top rank gets the online class. And lower rank gets the teacher. What would I need to say next?
Average of
the result.
You need to compare the result.
I'm not even close to done. Look again. Still can't even go to repeat yet. If a 2 is selected, bless you. Then what?
Then they get the online class.
Then the lower rank gets online, and higher rank classroom teacher. Now, this is a lot of detail. You probably could have gotten away with just saying, if a 2 is selected, then the assignment is reversed. You could probably get away with that.
Is that probably?
Yeah, it would be. Yeah. I would accept it on scoring. Now, what some of you are trying to say would work. What we need to say now.
Repeat.
Repeat for every.
Decreasing interval.
Just.
For every pair.
Thank you.
Hour.
Yeah, word, right? Woo! It's a match pairs design. So yeah, you would need to, and I'll say this again, this is actually one of the cases where a coin would be a good case. Heads is flipped, that means that the higher rank gets the online class, and if a tail is flipped, the higher rank gets the classroom teacher, and the other student gets the other one, right? Yeah. But then you have to make sure you say repeat for every pair. So I do want to point out, matched pairs design is just a special type of what?
Experiment.
Blocking.
It's a special type of blocking. Remember, it's within an experiment, right? But a matched pairs design, isn't that a homogeneous group?
Yeah.
That's a homogeneous group. That's a homogeneous group, right? So matched pairs design is a special type of blocking. That's all that's happening there.
Wait,
Yeah.
why would you have to repeat for every pair if you just have to, can't you just like flip it like one time and that determines?
Well, so remember, this is for one pair right here. All of this explanation is explaining who gets online class or the classroom teacher for this one block, this one pair. Then you have to do all of that work for each of the pairs.
Yes.
Now, I will say this. Yeah, I will say you don't want to say, oh, that if you do this one time, all of the higher blocks get the online class, because then all of the higher ranks in the block get the online class. Creates a confounding variable, potentially confounding variable. You have to repeat for every group. Yes, Raina.
So is there any other types of special type of blocking?
No, that's it. Match pairs. And we'll revisit these throughout the year. Okay. Quick notes. Selecting experimental design. So, there's a completely randomized design, right? But, what does blocking do?
Homogeneous.
Yeah, but what does it do?
It gets rid of potential compounds.
Does it get
Well, no,
completely rid of?
it reduces. It reduces.
Oh, there we go. Right. So a blocking randomized block design so if you didn't pick up on it, and that's totally okay, we can't eliminate confounding, but we can reduce the effects of confounding by identifying a variable, I'll say a potentially confounding variable. And create homogeneous, I'm going to call it blocks first. Create blocks, which are just homogeneous groups. around that variable. So it reduces the effects of confounding. So yeah, make sure you note that you would assign, not just assign, randomly assign treatments from within blocks. Yep. That could have been disastrous. Most get started like, you forgot something, Mr. Kenny. I'm like,
Right.
Yeah, randomly assign those treatments from those blocks. Any guesses what learning target number 2 is going to be about?
The one we just wrote
Special
Mixed,
type
mixed,
graphics.
mixed.
Guys.
So match pairs.
From.
Alright, so with a matched pairs, there's 2 options. You can either block 2 similar individuals together. And randomly assign one to a treatment. Other experimental unit. Okay. So that'd be 2 completely different experimental units. 2 different individuals. Anybody have an idea of another way maybe to do a matched pairs? Star?
Could you just throw the entire block in one, like evenly?
No. You always randomly assign half the block to one treatment, and half the other to the other treatment. Or if it's 3 treatments, right, to evenly split into thirds. But no, there's something that we talked about when it came to beards in the Mr. Wilcox
You split
situation.
it in half and you do the.
So you block on an individual, and then you split it in half. So you could do beard oil on one half of my beard and no beard oil on the other, because no one's going to have facial hair growth more similar to me than me.
Right.
So
Got it.
block on an individual.
Wait.
Is there a term for that? Or?
Yeah, it's still match pairs.
Oh.
Yeah, and randomly assign half to one treatment. Okay. I'm going to see if there's another language that mathematic uses, but yeah, going back to that beard context, right? Nobody has facial hair more similar to me than me. If you're testing different lotions, right? Everybody's skin reacts differently. So you put one type of lotion on one hand and the other type of lotion on the other hand, and see how your skin reacts, right? So those are things to consider about how a possibility. Yeah. The big thing, the only other thing they had on mathematic to note is the order of the treatments has to be randomly assigned. The order of the treatments has to be randomly assigned.
Can you do the beard oil thing for November, please?
Maybe for November. Okay. I'm going to leave this check your understanding for you to do, for you to think on your own. I'm going to finish, do the next activity, and from there, Yeah, I'm gonna do the next activity. If we have time, we'll come back to this. All right, so we've got hire a teacher. I gotta find where I put the resumes.
Jennifer Miller.
Jennifer and somebody else. Don't look at the next assignment though. Close your notebook, don't look at it.
Oh, look
I'll have to fight you.
Oh,
Do what? I'm not looking at it.
Don't look at it, close your notebook. Ah! All right, so here's what's happening. We're gonna hire a new teacher, a new math teacher. I know, like 3 weeks into school. Don't think about it too much, okay? So one of them is named Jennifer, one of them is named John. And so I am going to randomly assign you to read through the resumes and rank them on the back of how likely you would be to hire them. Make sense?
Well, yes.
Okay, now, Madeline already did it earlier, she got Jennifer, so I'm not gonna do one of those as Jennifer's. That's not spoiling, that has nothing to do with like what data we're trying to collect. Okay, so at this point, how could I randomly assign the resumes to you? What would I need to do?
You gotta label.
Label
So I'm
us.
gonna label each of you, 1, 2,
2,
To,
12.
1 to 13.
1 to
6,
Yeah,
9.
13.
1 to 13?
I got 13.
Do what?
13. Because there's not half of 15.
Well, I would still have to label all of you 1 to 13, right?
Oh, yeah.
Okay, so I could label everyone 1 to 13, generate
6 numbers.
6
7.
random numbers, please. 6 random numbers, and that group gets which resume?
Jennifer.
Jennifer, okay? Or if we randomly generate 7 unique numbers, those people get,
John.
so you can split up that way. The other option is, and it's like that's what I would go with. The other option is, I go to each student, I randomly generate a 1 or a 2, right? So I generate a 1 or 2 for Ethan. If he get a 1, then he gets Jennifer. If it's a 2, he gets John. And I keep going that way until I randomly assign half of the people to Jennifer, and then the other half get John. Or the rest of the people get John. This is not my favorite method. Okay, so let's do this. All right, so Ethan, you're gonna be number 1, Star 2, Charlie 3, Dixie 4, Ian 5. I guess I'll just go this way.
We're fine.
Emerson, so 6, you were 5?
I'm 5.
Okay, so Emerson 6, Raina 7, Kinsey 8, Andrew 9, Phoebe 10, Lorelai 11, Leah 12, 13, Sophie 13. Alright, so randomly, alright, so 13, 1 through 13, let's see. Number 13, you get Jennifer. Sophie, come read through her resume.
Yeah.
Rank her on the back.
Wait, how are you deciding that she gets to Jennifer? Or
I'm deciding that the first 6 get Jennifer because I've already assigned 1 Jennifer to Madeline. And I did do it randomly. Okay, just to clarify.
RNG.
Alright, 6, I don't remember who 6 was. You're Jennifer. Oh, Emerson, come on with it. Okay? 12, you get Jennifer. So yeah, that was you. 1, Ethan. 6 again. So did I give Emerson a second one? No. Sampling without replacement. So technically this is assignment. No, 1 again. 10. Phoebe, you got Jennifer. Alright, that's all the Jennifers. Now we got John. So whoever did not get 1 yet, you're John.
that's like all of them.
Okay? So read through the resume, then on the back, rank how likely you are to hire this person. Don't talk about it. You rank on your own.
I didn't want
What?
I didn't pay for it.
Well, I didn't want you to get one.
Don't talk about it.
Hey, quick, raise your hand if you got Jennifer. 1, 2, 3, 4.
Yeah, you didn't do it enough.
You didn't do this.
Who got Jennifer? Raise your hand.
Charlie, did you get
1, 2, 3, 4, 5.
Oh, word?
So you'll be Jennifer.
Preach?
Yeah.
Oh, darn.
It's random enough. Sorry. Alright, rank them, please.
Is it okay to write on this paper?
Yes, that is your paper. Write on it. You should rank it on the back. Shouldn't take too long. It's a pretty short resume.
Oh,
How old is she? Oh.
once you have your score, come write your score for whichever one you have up on the board.
Cashier.
Yeah. Right up there, please.
Try pop me.
Comment is better. Comment is better.
Not funny.
What happened?
Emerson said 6'7".
Girl, I got in there a long time before.
Guys, come on.
I'm gonna record this video.
6 or, you know, an occasional 7.
Ooh.
Okay. I feel like we're missing one.
Oh,
You
you're
had
missing
it, John.
one. You're missing one.
Oh, what do you want to put up there?
6 or 7.
Please don't. Charlie's there, just tell him.
Oh, this, okay, you're gonna write it, okay. I'm gonna do,
It's
okay,
not this hard.
a 3.
Dang! This just got way more interesting.
He's just trying to be.
Why
All
did I rank that high? He was not that good.
Okay. All right. So we hired a teacher. We're gonna come back to this data in a second. So we're building on the idea of explaining or identifying the importance of variation in statistics. We're about to talk heavily about a statistically significant difference within this context. So, fun fact, now you can look at the assignment. Your class just performed a modified version of the famous John Ginn study conducted by researchers at Yale. We're going to produce some studies. So yeah, they were the exact same person. Don't, yeah.
I know the person across from me.
Had exactly the same resume. So there's a whole thing right here. Yeah.
Wait, like this is like someone who works here, that's their resume?
No!
Somebody.
Golly. So, does anyone have an idea what they were testing at Yale when they did this study?
Like, maybe like male and female bias?
So, gender bias,
Yeah.
right, or sex bias. So, notice the resumes were exactly the same except for what?
The name.
The name, John or Jennifer. They even had the same last name. They had the same about me. They had the same contacts. Why in the world do you think they had so much that was exactly the same?
To see the same person, to see if gender is the sole.
Well, it's not actually a person. What?
To see if gender is the sole basis for
Okay.
the bias.
And be careful about the term bias, right? The way we talk about it with statistics. But if gender caused a difference in response, right? Okay. But why were all the different things? Why was objective, experience, about me? Why were those all the same?
Because you reduce.
Yeah. So what was it doing?
Homogeneous. Already had John.
Homogeneous.
We're not long
Direct
ago.
control.
Almost like
Homogeneous.
Direct control.
Direct control of potentially confounding variables. Guys, listen, the only difference between the resumes, 100%, was the word Jennifer versus the word John. Everything else was kept the same. When everything is kept the same, that's called direct control of those potentially confounding variables, right? So, the only difference really between these, well, there really shouldn't be any difference between these, but apparently we prefer women in this class to men, right? Okay.
I didn't look at the max rating you could give, and I thought the max rating was a 10, so I was gonna give her a 7 out of 10.
Oh, so Jennifer would have been lower? That's too late. Sure, you're saying it now. So here's what we're looking at. All right, so the resumes you evaluated were fake, just part of an experiment. And so put your the ratings for John over here, the ratings for Jennifer right there, and Madeline gave Jennifer a 5. Nope.
I'm sorry.
No, you're not.
I'm not.
I know.
Wait, what?
You're writing those scores in the boxes.
Oh.
Oh.
It's just there was more boxes.
She said
It's just 6.
Yes, there are more boxes.
Why did you give him a 3?
Because I don't like the words he used.
It had nothing to do with the gender, got it.
Oh, I know, I didn't even pay attention to his name. Also, I
I
didn't
thought
like.
it was Jennifer at first.
Okay. The sample mean for Jennifer, for John, is 5 point. Ooh, let me make sure I have the right. 5.2857. Whereas this sample mean was 6. Okay? And so, in all reality, because of the same individual, we should have gotten the same score, right? But we clearly didn't. And I will say it was hiring discrimination specifically that they were looking at Yale, I think within the engineering world. So I could pull that study up and later look at it. But there's issues of hiring discrimination in the field of academia, for sure. And so they were testing, and they tested this on professors who had the ability to make recommendations on who was hired. And they were testing it out to see, hey, is there gender bias here, actually? And I'll bring the study up more tomorrow, but I just want us to look at these two means. Now, so write down the John mean score, the Jennifer mean score, and then the difference between those two would be a negative 0.7143. Now, in the context of academia and the context of like higher ed academia and engineering, who do you think typically had the higher average rating?
Men.
The men did, right? And so that is a legitimate thing of like the men, even though they're the exact same resumes, men generally had the higher rating. So this value was positive. What does this value being negative tell us though?
Woman.
It's
That-
opposite.
That Jennifer.
Jennifer.
That and not higher in secondary education. Like within like K through 12,
Yeah.
more women are preferred than men.
And not necessarily, but at least with us, right, Jennifer was preferred. And that's just what I would say is, right, our average score for Jennifer was higher than our average score for John. And so what we're going to do is, oh no, did I remember to grab index cards from home? This could
Oh,
be
wait, I
all
have
bad.
index cards in my backpack.
I also have index cards in my backpack.
I have like 6.
You have how many?
And who said that?
Like 600.
Give them to me.
Word?
Okay?
That is not 6.
Because I actually need. Is that all you have?
Yeah, I lied.
No, I need like 600. I need like.
Like
I
6 or 7.
I need note cards because I need 14 for each person.
I have
All right, there we go. Okay,
Oh my
thank you.
goodness.
I'll repay you one day. So here, get 14 per person. Okay, 14 per person. 14 per person. 14 per person. And write those scores. Okay, hear me on this, guys. Write those scores on each of the sheets of paper, right? So you don't have to label it John versus Jennifer. Okay? You just write down these scores.
I got these.
They're like one number per. No, please.
And if you have too many, hand it back to me so I don't have to buy Ethan too
All
many.
of them on one or like one on each one?
So you're gonna write this on one card, this on a card, this on a card, this on a card. And then you're gonna write it down, you're gonna shuffle them up.
7, 8, 9, and then 9,
I need more index cards.
10,
There you go.
I need way more than that.
We have 2.
I didn't hand that enough, that's my bad.
Here.
There you go.
If you need more, I have an open stack
Here you
right
go.
I do.
Alright.
Crummy card.
7, 8,
Yeah,
9.
you need more as well?
I need 5.
I thought I handed out more than enough.
Everything. Hey, sorry, yeah, 5.
Yeah, get a handful more. Thank you. And Dixie needs more. Actually, I got you.
Yeah, we're just running
I think that's enough.
Yeah.
Alright, here's, should be enough for the rest. Okay, guys, write down each of these numbers, right? onto a separate index card. You should have 14 index cards. Okay?
This expired in 2012.
Are you serious?
Are you cool?
What the heck? Where did
You tried to poison me.
Oh,
Okay?
What happened?
I think I'm right.
Oh,
Those
Yep, you're writing each of those scores on a different index card. So 5, 6, 6, 6, 5, 6, 3, 6, 7, 6, 6, 6, 6, 5 on separate index cards. As soon as I said it, I was like, oh, someone's gonna freak out.
Did you mess up?
Okay.
5, 6, hold on, I'm like gone. 5, 6, 6. That's
Where's all the,
1,
there you go.
6, 6. Wait, hold on. I'm
This is my presentation number.
All right.
I see it everywhere I go.
Andrew, where's yours on?
Wait, we don't have to like split them up or anything, right, by name?
Okay.
Oh, you got 6 and 7?
What is it?
All right. So here's the thing. We got 2 minutes, so we're not gonna be able to finish this. What I need you to do is I need you to shuffle up those cards, which is going to simulate what really important process in
RNG.
statistics, randomization at least, right? It's not a random number generator, but it's randomization. And draw the first 2. Let's let the first one be for John,
Whoa.
and the second one be for Jennifer. Okay? So let the first one be for John, the second one be for Jennifer. Okay, so put those numbers down on your thing right here. So John and Jennifer.
Keep doing it.
And keep doing it for the rest of them. And
Wait, but you can't see the data.
you don't. So tonight, what I need you to find is the mean for John and the mean for Jennifer. So find the random assignment. The first one will be for John, the second one for Jennifer. So write those scores down, find those means. You can grab a calculator if you need to. The DYU will have to be, it'll have to be Wednesday, but we'll finish this up first half of class tomorrow, and we'll do our, now figure it out. We're gonna have to start the next unit in the middle of this unit before we test. But DYU will be on Wednesday. Prayer model will be due on Wednesday.
Okay.
When the DYU is.
You push it back?
Crap.
Wait, what?
DYU is Wednesday. Prayer model is Wednesday. Tomorrow night in